Everybody loves Riemann sums. Actually, not everybody loves Riemann sums. I personally hate them, but the idea behind it is you have an equation that when graphed is going to look a little something like this, right? And you are creating these like little boxes that's supposed to help you estimate, give or take, the volume underneath that curve. And nothing's ever perfect because if I were to use these little boxes, I mean, I'm overestimating here a little bit. But that's the idea of a Riemann sum. You are looking at rectangles and you're estimating the area under a curve, or in this case, a line, using those rectangles. In this case, we are doing right Riemann sums, which focuses mainly on the right side of something. So if we were looking at the integral between 0 and 6, and if this is supposed to demonstrate x plus 1, here's 0, here's 6. We're splitting this up into 3 equal subdivisions, so 3 equal things, and so I have to figure out what the right side of it is going to look like. Now, it's a little obvious, but if you don't have it obvious, we would call figuring out that difference the change of x. Now, the change of x is calculated by doing, this is b, this is a, this is your upper limit, that's your lower limit, so you do b minus a over the number of subdivisions that you are told to use. So in this case, you're going to do 6 minus 0 over 3. That's going to give you 6 over 3. It's going to give you 2, which means every one of these is going to be 2 units long, 2 units long, 2 units long. Now, since we're looking at the right side, we are focusing on the fact that you would be 2, you would be 4. We're going to focus on 2, 4, and 6. So those are going to be my endpoints. Okay? What I do now is I evaluate this equation right here, which I'm going to call f of x. We evaluate at each of these 3 right endpoints at 2, 4, and 6. So I'm going to find f of 2, I'm going to find f of 4, and I'm going to find f of 6. What that does is that gives me the height at those spots according to my equation that I have written right here. So f of 2, and this is very friendly, f of 2 is going to be x plus 1, so 2 plus 1, which is 3. F of 4 is going to be 4 plus 1, which is 5. And f of 6 is going to be 6 plus 1, which is 7. Okay, so easy peasy. Now what I do next is I calculate the Riemann sums by multiplying the change of x to each f of x. So since u turned into 3, and u turned into 5, and u turned into 7, essentially what I need to do is I need to add up the area of all 3 of these. Since each of these have a length of 2, I'm going to multiply 2 to 3, 2 to 5, and 2 to 7. Okay, so 2 times 3 plus 2 times 5 plus 2 times 7 is going to be 6 plus 10 plus 14, which is going to add up to a nice perfect 30. So the area underneath this line is estimated to be around 30. Is it 30? No, because there's an overestimate here because these rectangles go a little bit above and beyond. But my estimate using 3 subdivisions is going to be 30. If you have more subdivisions, the estimate's greater, it's better, it's closer. Not greater, I shouldn't have said greater, it's going to be closer. But yeah, that's how you do a right Riemann sum to something that looks like this. Something that looks like this. Oh, like and subscribe.